Hi everybody, and welcome to the API Platform Conference. For the 10th anniversary of API Platform, the pressure was maximal, and I wanted to show you a new feature. So I will introduce you a new feature for both API Platform and FrankenPHP. My name is Kevin Dunglas, and I come from this very city of Lille. I'm the API Platform creator, even if now it's Antoine Blucher that is who is doing most of the work. Now that I have time, thanks to Antoine, I work a lot on other projects, including FrankenPHP. I'm also a maintainer of Symfony and PHP, and I'm the co-founder of Les-Tilleuls.coop. Sorry for the name, it's not pronounceable in English at all. So, Les-Tilleuls, this means the lime tree in English, and it was the name of a bar in Lille for the story. But anyway, we are doing a lot of things, especially we can help you to finish your projects that are in struggle with PHP, with Go, with JavaScript, and we are creating projects from scratch. We can train you to many technologies, and we can also create cloud platforms for you. So don't hesitate to come to our booth to speak about that. Sorry. Okay. Our company is a worker cooperative. That means that the company is entirely managed democratically. We vote for the decisions, and that the benefits of the company are shared between the employees at the end of the year. So, it's the 10th anniversary of API Platform. We have done a lot since the very first commit of the project 10 years ago. At the very beginning, it was a teeny bundle for Symfony, and the main goal was to be able to expose a state-of-the-art web API just by creating the public data structures that we wanted to expose through the API. And it's still the same goal, but now we have many more features, and we have also tools client-side to let you generate and build client applications consuming the web APIs. Also, it's now a standalone library that is still available as a Symfony bundle, but that can also be used with Laravel, and that can be used without any framework at all. In the beginning, as you can see on this screenshot, it was only 2,000 lines of code. Now it's a bit more, but still, it's still open source, and you can still contribute to it, and we still try to make the code as readable and as extendable as possible, so don't hesitate to read it and to contribute to it. So, these 2,000 lines of code are now many more lines of code and components and docs and contributions. So today we will celebrate this birthday. 10 years of API Platform, it's mostly 10 years of community. There are almost 15 stargazers on GitHub on all repositories. The main repository, called API Platform/API Platform on GitHub, is almost at 10,000 stars. We are close to it. Maybe if you go on the repository and click on star, it will help, and maybe can we reach 10,000 stars on GitHub today. So please, if you don't like the repository, do it right now. I created the first commit in my room 10 years ago, but now there are almost 1,000 people that who contributed to API Platform, both to the code, to the documentation, to speak at events. There are a lot of people involved, and it's the main strength of API Platform. If you need help, you can always count on the people on the API platform Slack channel on the Symfony Slack, and there are many people here to help. There are also a very active community on GitHub discussions and on Stack Overflow that what is making developing easily with API platform possible. So thank you to everybody. Thanks to all the people contributing and helping the community online. API platform now has support for Symfony and Laravel. So that means that since last year, we got a lot of contributions from the Laravel community, and so I'm very happy to see the PHP family working together on project in common between the two main frameworks. So I think that it was one of the goals of the API platform community to bring Symfony and Laravel together, and that starts to be the case, and we are now, both communities are working on many projects that are shared between both framework, and that's a very nice achievement of the API platform community. Finally, while working on API platform, we had other ideas that was related in the beginning. So projects like Mercure, a real-time solution written in Go, FrankenPHP, a new application server for PHP with very impressive performance, and many Symfony components like the web link component, the property info component, most new features of the Symfony serializer component, the new JSON streamer component from Matthias, have started as internal code of API platform and have been made available for the community at large because it could be used for your other use cases. So it's also one of the things that we are very proud of. Today is API platform birthday, but it's also Niels' birthday. So a round of applause for Niels, please. Happy birthday, Niels, and I hope that you will be plenty at Niels' talk and that we will celebrate. This is the biggest API platform conference ever. It was sold out. We are 400 in Lille and 200 more online from all over the world. For the first time, there is 3 tracks, including a French-speaking track, and there are a lot of incredible speakers, a large partner area with some booths, and huge parties. I hope that you will be there for Fabien's keynote tomorrow morning anyway. The community, it's composed of people making things. And one of the most prominent people in the API platform community was our friend Ryan Weaver. Ryan was the creator of the official API platform screencast, and he contributed a lot of code. He shared his knowledge during this very own conference in Lille. Ryan passed away a few weeks ago. Let's make some noise for Ryan and all his work. And remember Ryan, please, some noise. Ryan helped a lot of people of the PHP community at large, and now Ryan's family needs our help. There is a GoFundMe campaign running to get some money for Ryan's son. So if you don't have done it yet, please scan this QR code and make some donation for the son of Ryan. One key idea of API platform is to be able to support many API architectural styles with the same code. That means you can describe the public data structures that you want to expose to APIs, and API platform will provide you all the infrastructure code allowing to make this API working. A quick example extracted from the documentation. You can use the PHP language as a way to describe the data structures that you want to expose publicly through a web API. Basically, it's a data transfer object. To make this explicit, you can use the type system of PHP to say that the ID property will be an integer and that the title property will be a string. And you can add some human readable documentation by using the PHP doc annotations. And that's all you need to expose web APIs in a lot of formats, in a lot of architectural styles. With the latest version of API platform, with the single PHP class and some configuration, you can enable Hydra APIs. Hydra was the first format supported by API platform since the very first commit. It's an API specification to build state-of-the-art REST APIs that has been created by Google, and it's still the default choice, and we have a lot of front-end tools that leverage the power of Hydra in API platform. Next, Hamza Amrouche introduced support for OpenAPI, which is a way to describe in a machine-readable way the web services exposed by a system. So we also have native support for OpenAPI, and we are able to describe most of the formats supported by API platform through OpenAPI specification, which is using JSON schema under the hood. The same year, Hamza also introduced support for HAL, which is a simpler hypermedia format for REST APIs than Hydra, but that is still very popular. The main idea is that API platform will take care of generating the proper JSON conforming to this specification for you. You don't have to do it manually, and it's quite hard to do that by yourself anyway, especially with Hydra. In 2017, Baptiste Meyer introduced support for another popular community format called JSON API. JSON API is a popular way to standardize the JSON output of your web API, and it's still supported by API platform. And Facebook introduced a new way to create web APIs that is not following at all the REST architectural style. It was called GraphQL, and it is, since the introduction of this API design system by Facebook, very, very popular. Alan Poulain did a lot of work to make the core of API platform more modular and to be able to expose the data managed by the API platform API, both using REST formats like Hydra or HAL or JSON API, and using GraphQL. The main idea behind GraphQL is that the client can specify through a query language the exact data that it needs, including all the data in the relation graph that it wants to retrieve, and the server will fulfill this request and send only the data that is needed. And it's also supported with API platform. You just have to enable it in the configuration. And with the same code, with the same PHP class that I showed in the previous slide, you can have both a REST and a GraphQL API. And finally, in 2018, I introduced support for async APIs in API platform using the Mercure protocol. Here, the idea is that instead of having a client that will pull the data when it needs it, the server will push the data to the client using server-sent events when the data change. It means that a user creates a new entry in the database. Automatically, API platform will detect this change and push it to all the connected users. And this is also possible using the exact same code, just the definition of the public data structures that you want to expose to the API. You just have a single configuration line to add to have support for all of these formats. So one of the key points of API platform is to be able to support different API styles useful for different use cases with the same code, and very easily because the framework takes care of implementing these complex specifications. Antoine will show you a lot of improvements made to all these systems during his keynote this afternoon, so don't miss Antoine's keynote. There is one other API format that is very, very popular, but that we had never managed to support in API platform, is gRPC. gRPC, for gRPC remote procedure calls, is an open source framework. When we say framework, let's say it's a specification to build high performance APIs that has been created by Google and that is very popular in the Google ecosystems. It's not following the REST pattern at all, and it's very different from GraphQL too. Basically, it's a remote procedure call mechanism. That means that you will call functions through a network interface. So it's not following the REST architectural style. And it's not using JSON at all. It's using a binary format called protocol buffers, which is also a format very optimized for performance that has been created by Google. So it doesn't work the same way as the usual JSON APIs. It's using binary formats, and it's using very advanced and low-level features of the HTTP2 protocol for the network transfer. The main benefits of gRPC are that it's fast and efficient because of the binary protocol buffer format and because of the advanced features of HTTP2 that are used by gRPC. It allows to have very low latency communications between clients and server. Also, unlike JSON, but a bit like JSON LD, the format is strongly typed. That means that you define a strict schema for messages, for the request and the response, and you will have a type system that will enforce that the data is correctly typed. So it improves the reliability of the API and the developer experience. And as Google is using a lot of different programming languages, it has been created from the ground up to be language agnostic. There are code generators provided by Google to generate the data structures in many programming languages from the protocol buffers definitions. So that means that it's very useful when you need to have, let's say, a mobile app or a connected device communicating with a server that will itself call another service written in another language, for instance. So gRPC is not a silver bullet, but it is useful in several popular use cases, especially for advanced big projects. It is useful for microservices because it's a fast and reliable way to have different services written in different languages communicating together. It is very popular in the IoT field because of the efficiency of the binary protocol, and it is also very popular in critical systems or for critical part of large systems. So for instance, it could be very useful if you have a large system written in PHP, but some components that you want to be very fast and so written in other programming languages like C, Rust or Go, or very reliable. Here is a typical gRPC architecture. You will have a gRPC server that will communicate with other part of the system, server side, like a Ruby application, or with devices that will call the server through the public internet, like an Android application or an iOS application. An interesting thing is that gRPC allows real-time communications. So you can create a socket and send that data in both ways in real time. It's not possible with HTTP without things like Mercure or WebSocket. It's built in with gRPC. So to define a gRPC API, It's quite easy. There is a text format that is language agnostic that you need to use. So in this example, we create a service with a function that can be called through the network called sayHello that takes a hello request as parameter and returns a hello reply. Then we define the messages using protocol buffers, so it's the protocol buffer definition format. So there is the shape of the request and the shape of the reply. Of course, this one is very simple for the conference, but you can do very advanced things. And you see that it's strongly typed, even in the definition. Then to write a server, it depends on the language that you use. There are official tutorials for many programming languages to create the APIs, and most of them are using code generators to generate the code corresponding to the definition. There is an official tutorial for PHP. And in PHP, they say, you can only create gRPC clients in PHP. Use another language to create a gRPC server. And that's the reason why it's not supported yet in API platform. Actually, to implement the gRPC protocol, which is using advanced feature of HTTP2, you need direct control of the HTTP2 connections, and it's not possible with FPM. Actually, it's very hard to do in pure PHP, and so it's not supported. So you can query a gRPC API using PHP, but you cannot create one using pure PHP. Fortunately, FrankenPHP is written in Go and has, since the very last version, support to write extensions to FrankenPHP itself in Go to expose more features to PHP. So if you don't know FrankenPHP, watch my keynote of last year. It was mostly about FrankenPHP. Basically, it's a modern application server for PHP that is very easy to deploy, and that has a mode called the worker mode, allowing to improve very significantly the performance of PHP applications. Antoine will show you some benchmarks for API platform during his keynote, and you will see that it's impressive. It has a lot of features not available in FPM or Mod PHP, and it is now supported by the PHP Foundation. It works with any existing PHP app, and it has been available as part of the API platform distribution since something like 1 year. So if you are using a recent version of API platform, you are already using FrankenPHP. Since version 1.8, we added a new feature, the ability to create PHP extensions written in Go without to write a single line of C code for simple use cases at least. These extensions can use all the features of the Go programming language, including control over low-level network connections, like we need for gRPC, concurrency with Go routines, and basically you can use all the existing Go libraries to extend and improve your PHP applications and expose PHP functions that are written in Go, or call some PHP from code written in Go. Both ways are supported. Alexandre has been one of the main authors of this new feature, and don't miss Alexandre's talk this afternoon. With extension, you can very easily register a PHP extension in pure Go. There are helpers for that. You can convert the PHP types, like arrays and strings and int, in Go types. And you can do the other way, convert Go types in PHP. There is a code generator for simple use cases to be able to generate a PHP extension just from some commands in the Go code. And there is a new feature that is only in the main branch for now, but that we will release very soon. The support for external worker. The main idea is that, in addition to the worker mode allowing to handle with a long-running PHP application HTTP request, we could do other things in a long-running script. For instance, we could dispatch Symfony Messenger messages asynchronously and have a PHP script managed by FrankenPHP that will handle these messages asynchronously. That's something that is possible with this new feature that is in main. Rob Landers is one of the main authors of this feature, and he is also talking at the conference, so don't miss his talk. It will be about this part. This new feature allowing us to create a new extension for FrankenPHP called FrankenPHP gRPC. The code is available right now on my GitHub page in the FrankenPHP gRPC repository, so you can try what I will show you during the end of this talk. It's already there. The main idea is to run a gRPC server managed by FrankenPHP using the official gRPC Go library provided by Google. Then this extension will call PHP functions running in a long-running worker to let you write the business logic in pure PHP. So the gRPC request will be converted in a PHP data structure, passed to a long-running PHP script. Then you will have the opportunity to write your own PHP code, return a gRPC response, and the extension will convert it in a Go gRPC response to send it to the client. You can write the service handlers in Go as if you were just using the Google library. You can write them in pure PHP, and you can also do a mix of both and have some Go code that will do some business logic, then pass to an existing PHP code, for instance, then do some post-processing to the data returned by PHP. This extension is entirely written in Go, not in C at all, and is entirely designed to be used with API platform. So, to write your own gRPC server with API platform. Just a quick note, the extension has been designed to work both with and without API platform. So you can also use it without the framework, but with some handwritten PHP code or with other frameworks if you want. So the first step is to create a Go module. It's like a composer package, but for Go. Then you need to define the service that you want to expose through your gRPC API using the same text language as for any other gRPC API. So it's the same example as before. After that, you will use the generator provided by Go gRPC to generate the Go code that will be able to handle what you have defined in the protocol buffer file. And it's entirely automated. It's something that is provided by a compiler created by Google. At this point, you need to call the PHP gRPC extension to register the server. So it's just a factory method. You need to register the services that has been generated by the Go code generator, and you can pass as many options as you want. The gRPC Go library has a lot of features, and you can support different versions of the protocol, authentication, and many, many features. It's in this factory that you will set the options. So you have full control over that. Finally, you have to implement the method that will be called through gRPC, through the network. So you have to do it in Go. In this very simple example, I take the gRPC request, I convert it in a map, in an associative array in Go, and then I call the handle request method of the gRPC extension to pass this associative array to the long-running worker that is waiting to do something in pure PHP. The worker will do its work in PHP and return an associative array. The associative array will then be converted in my code in a Go struct and returned by the gRPC server. Here, it's a very naive implementation, but you can write the code that you want. For instance, you can do the hard work in pure Go and just call some legacy services written in PHP when you have done the hard work if you want. You can implement some methods or some functions in pure Go and some others that are less critical in PHP. You can mix everything as you want. And finally, here is the PHP code. So it's very similar to the traditional worker mode provided by FrankenPHP to handle HTTP requests. Basically, you have a function provided by FrankenPHP handle request, and this function takes a closure as parameter. And every time a gRPC message is received by the gRPC server, the callback will be called with the data that you passed in Go as parameter. And finally, the data that you will generate in PHP will be returned to Go, and you will be able in the Go code to serialize it in the protocol buffer format. Here I'm using associative array, but you can use any type. You can basically pass and return any data structure, and it will work as long as this type is supported by the FrankenPHP extension type converter. Alternatively, you could load and use API platform. In this example, I take the associative array passed as parameter, I convert it in an entity marked with an API resource by API platform using the object mapper components introduced by Antoine during the latest Symfony version. Then I call the API platform processor to save the data in database, do all my existing execute all my existing business logic that can be in my REST or GraphQL API. And finally, I convert back the API platform resource returned by the processor in an associative array. So it's how you can integrate this feature, this new extension with API platform. You need a CADI file to start FrankenPHP, so you just need to register FrankenPHP and pass some configuration to the gRPC server, including the port that you want to use and the number of workers that you want to run in parallel. Finally, you run the command as usual to build FrankenPHP, including this new extension, and you call run, and that works. You can use things like gRPC UI, and you have a gRPC server using FrankenPHP and calling the API platform logic that you already have for your GraphQL or REST API. Of course, it's available as a prototype. It's still very experimental. We need to polish a bit the code allowing to do that in FrankenPHP itself, and we will tag a new version containing what is needed to have this extension very soon. The code of the extension itself is also available, and you can use it as an example to write your own extensions. For instance, we could create an extension that would be able to handle Symfony Messenger messages directly with a single service provided by a FrankenPHP extension without requiring Redis or RabbitMQ or something like that. That's something that I would want to do. And it's possible by using the same approach. We would like to create a code generator for the Go handler to not have to write these 10 lines of code for simple use cases. So it's something that you can contribute if you want to help. We would also like to be able to generate the proto files, the text files describing the gRPC API from the existing class mapped with the API resource API platform attribute. It should be easy to do, and it's something that is on the roadmap. And finally, we would like to polish the API platform integration and provide a support composer package to provide the worker script for the gRPC server, so it will be even easier. So if you want to help, everything is already available publicly on GitHub, and pull requests are very welcome. Today is a day of strike, so it has been maybe complicated to go in Lille. I hope that you will be there for the conference, but at Les-Tilleuls.coop we try to act for a better society too. So if you want to go to the demonstration, there is one in Lille too. Thank you very much.